So networking, I mean, we all have networking right in your palms. You have your networking, your phone that you have is a network. Your internet at home is a network. So every day you use a network, but you don't know that you are in a global network. We are in a global network. So you can see on the diagram here, you can see everyone is connected. We are all connected. It's a network. But let's start from a personal network. Personal network is your personal network that you have, your network at home. Your modem, your router, that is your network. That is your gateway. That gateway is your firewall. Your gateway gives you access to the internet, and it connects multiple computers at your house, at your home. At your home, you might have multiple computers using that modem. You might have multiple people in your home using that modem. So that is a network. They all connect through that modem, which is your gateway, to communicate outside, to go outside to the internet. That's a personal area network, PAN, personal area network. That is a network. So you have a network at home, and you are the network administrator. You administer that network. If you go to your router, if you are connected to your internet and you go to your Windows prompt, if you type ipconfig, ipconfig will tell you your network, will give you your network. You see your network information. So if you look at my screen right now, what I've highlighted, that is my network. My network is Comcast, IPv6. We're not going to discuss IPv6 because it's not implemented. They're trying to start implementing IPv6. We are still on IPv4. So if you come down here, you see IPv4. That is my IP address. If you see IPv4, if you do ipconfig, I have another section which have all those commands. You can type, you can practice those. So if you do ipconfig on your computer, on your DOS prompt, you will get this information. You see your IP address, this is my IP address. This is my subnet mask. And this is my default gateway. What is the default gateway I just mentioned earlier? The default gateway is your router. The router that you have at home for your internet is your default gateway. That's your gateway. That's like your firewall. That is, that is the place that takes you to the internet, and you can allow people to come in, and you can block people to come to your network. You can do it right there on your router. So if you see this IP, if you see this number, you always end on 1. Your gateway, most gateway always have the 1 as the last digit. So if you do ipconfig, you see these numbers. Yours might be a different, if you're on a different internet provider, your IP address might be different. But if you
yeah, you have the same because you have Comcast.
Oh, you have the same?
Yeah.
Okay, so okay. But you see, we have the same, but we're on it. You're on your private network, on my private network, right?
Right.
So and we are on a private network. Private network is a network that is private, it's internal.
Yeah.
Right? You cannot from a private network, you cannot go to an internet on this IP because this is a private IP address. We have a whole section, session we're going to do for IP addresses because it's very important to understand IP address. But this IP address that you're seeing, the one you have 10.0.0.1 is a private IP address.
So you guys cannot have the same IP, you and Cheju, right?
Yes, we do, because he has his own private network. So these are private IP addresses, right? So he has his private IP at home. You can have a private IP I create, on this network. I have my own private IP. They gave me the 10.0.0.1, and he can have your own. So those are private IP. Anybody can use private IPs, right? But when it comes to public IPs, those are ones that are very scarce. There's no two. There cannot be two public IPs, because public IP is on the internet, right? Public IP will take you to the internet. It's public, right? Anybody can, I can ping it. I can, it's public IP. So that one is, on the internet is public, but private is internal. Just for your internal users that you use private IPs. Like I said, I have a whole session for IP addresses, because IP address is good to understand. Because if you understand IP, you can understand how you can know how to maneuver around, do searches on IP. If you look at the IP, you can tell it's a public IP or a private IP. Because private IP, they have different numbers. They have 10.0.0.0 is the private IP. So on my private IP, if you take this number, your private IP, you go to the internet, you go to your browser. Are you guys seeing my screen?
Yes.
Okay. So if I open, are you guys seeing my screen now? And it says infinity.
Yeah, we do.
Okay. So if you do that IP config that I did, right, on that DOS prompt, you see I did IP config here. I took this IP address, my gateway. If Elias, or was it Elias that have the same gateway? So if you put it in any browser, if you open a browser, if you do IP config.
Yeah, I did open the browser. I typed it there.
Right. Did it come up? Did something come up?
Yeah, it come out. I think different one, Xfinity and some of
Okay,
some
see?
of the other.
Okay, perfect. So now, from the IP address, you can tell us that that's our gateway. Now, if you know your password to your gateway, you log in. Now you are logging out to your network.
Okay.
So when you log into that network, it has a firewall there. It has things that you can create rules. You can block people. You can allow people. You can do things. That is your gateway. So every network has a gateway. So your personal network at home, your router, is a gateway, and that's how from that gateway you can start accessing different networks like internet and stuff like that. But that's another thing, because from the private network to connect to a public network is something that you have to do called NAT. NAT, you have to NAT. do it in that. You know, we'll look at that when we do IP address. I just want to show you guys how your personal network, how your personal network at home is set up, and how you can see your IP address at home on your internal, because it's right now it's your internal network, it's your private network, it's internal. You have your own IP address. If you have another computer at home, you have like multiple people using your internet. If they do IP config, the IP address is not going to be like yours. Say mine is, for example, mine is 12. You see, so your network will have 10, because my gateway is 10.0.0.1. So my IP address that is assigned to me on my computer right now is 10.0.0.12. So I have from 2 all the way to 254 in this my private network. So anybody that connects to my computer, they will be assigned an IP address. They'll be assigned a different IP. We can have 2 IPs on the network. That's a duplicate. So if somebody is on your network at home, if they do IP config, the IP will be maybe 15, like mine is 12. Somebody might be 15, somebody will be 16, 17. If I have 20 people on my network at home connected to my router, this router right here, my router that will just look, you know, I don't want to log into my router, but if I log in, we'll see all that stuff. But you know, but that's how you see how your private network at home is set up.
Yeah.
So when you are looking at network, you're looking at how everyone is interconnected by social media, by wireless, by all the apps that we have that we communicate with each other. That is network. And as a security analyst, you are coming in to protect that network. Because when people are logging in from different locations, communicating from different applications on the in the internet, you know that a lot of things can happen, malicious. So your main goal is to understand how you will protect that network, so that if any malicious event occur, you will be there to protect. So we have seen our personal network. There is social network, which we use every day, which is social media. There's mobile network. We use it every day. You have it in you have your mobile network in your hand. When you communicate and connect to all these devices or websites or social media websites you connect to, that is networking. You are connecting to from one device to another. And everything with the internet now, everything is global. Interconnection among two or more computers or computing devices. And when we talk about networking, there's always a network administrator. When you are working in its IT department where you have a SOC, there will be a network administrator that manages the network. But just look at the concept that you have your own personal network at home, and you are managing your network because you have multiple computers at your house connecting to your network, and that they're sharing the same router. We see that you can even log into your network, and then you can say, I don't want this computer. You can if you log into that network, that your personal network at home, your gateway, if you log into that gateway, you will see all the computers that are connecting to your network, and you can allow and deny any of those computers to connect to your network. So, for example, if you have kids, you don't want them to connect to the network, you know, at certain times or whatever. You know, you can do that also on when you connect to your gateway. You can block and allow computers even within your personal network. If you can connect to that gateway, if you know your IP, log into your gateway, you can manage that network. You can control who you want to connect to that network, who you don't want to connect to your network. So when you are on a corporate network, you have different devices that are always connected to the network. You have your laptop, you have desktop, you have your servers. This might be an email server. You have more laptops connecting from different locations. And all of them are connected to the internet. How are they connected to the internet? Through wireless network. There's a part of the network connection which is called VPN, Virtual Private Network. If you have multiple locations, if you have an office in Houston, and you have another office in Dallas, another office in New York, how do they communicate? Because all of them are the same company, so they're using the same application. They're using the same tools, so they have to communicate as one company. How do they communicate? How are they tied together? So when we go down the network slides, you'll see how they can be local area network and they can be wide area network. That's how they are connected. That's how companies will connect their network. They have a wide area network. They have offices at different locations. And these offices are connected to each other. I mean, why do we even need networks? When you have network, you share resources, you share files, you share a printer. If you have an office of 100 people, you're not going to have 100 printers on everybody's computer, everybody's desk. You have a printer which is on the network, a big printer which is on the network, sitting somewhere in the office that you can just print something and go and pick it up, and everybody in that floor or in that unit use that same printer. So that's a network printer. You have disk drive, you have drives that you can upload files. Network drives. So that's the important thing of having a network, because you share information with entire group or company. And you see the advantages: data sharing, hardware sharing. You can have one server, and you can have one Active Directory server, and 1,000 people connect to that server and share resources. Internet access, internet sharing, data security and management is better when you have a shared network. Performance, entertainment, and there are some disadvantages, but overall, networking is very, very critical and important for any company. There are different types of network, and we just discussed the first one, the one that we discussed, which is your personal network at home, which is a personal area network. You have a router. It's a modem. At home we have modem, and your router is connected. You can do a wireless router, wireless printer connected to your router. You can have laptops, printers. You can have headsets, desktop, handheld devices. your phone, everything connected to your private network. The other type of network that companies use, any company that you work for or you're going to work for, they have a local area network. So you go to a company, they have 10 floors or 5 floors. They have all those floors have users, different departments, accounting department, human resources, computer department, IT department. How do they communicate? Through a LAN. So you have switches and routers that are in the data center that have connectivity to all the devices. So when you are sitting on one floor, you can communicate and share files with the person sitting on the 5th floor. In this example, if you look at like a university campus, for example, how is the network set up? It's a big campus. They have all different types of departments. They all communicate with each other through a local area network. They have switches, routers, and firewalls, email servers, printers, all communicating with each other. Why are we even showing doing this network slides? Because when all these computers are connected to each other, there are always going to be some kind of issues. There will be issues that maybe a hacker trying to infect a virus on one of these computers, and then the virus will spread to these other computers. And you, as the security analyst, will have to perform some type of investigation. How did the virus get into this computer? And how can you protect the virus to go to the other computers? But as a network security analyst, you have to know how the network is set up. When they say local area network, You understand? Is a network that have multiple computers, and it can be in a local area. They have multiple locations. They're all connected to each other. A user can call from one building, having issues, connecting to some application that is in another building, another location. You have to know that how the traffic left that building, how that location to the other location, what happened. These days, they have wireless network. So you have the local area network. If you take your laptop, you go to the office, you have a local area network. If you take your laptop and you go to the office, you put it on your docking station. You put your laptop on your docking station. Most companies now, they have a wireless network in their internal environment. So if you put your laptop, take your laptop and put it on your docking station, and you turn it on, you will log in. You put your username and password, you log in. When you log in, you are connected to the network, and that is wireless. Most offices now, they use wireless network. So when you take your laptop off your docking station and go to a conference room for a meeting, you don't need to, there's no cable. You're always connected to the network because it's wireless. But before, when you take your laptop, take it to the office, you have to make sure there's a cable, a network cable connected to your laptop. Because if the network cable is not connected, you will not have network connection. So when they brought in the wireless networks, it makes things very easy. We don't have to have cables running everywhere, to every desk for you to connect to the company network. No. Now all you have to do, take your laptop, you put it on your desk. If you have a docking station, you dock your laptop, and when your laptop turns on, you just type in your username password, you are connected to the network. So we saw a local area network, which is local to one area, one office. But if you have a local area network at one office, and you have another local area network, the same company, have another office in another location, how is that? What kind of network is that? Because now you had a local area network, which was local. Now you have another network in another location. So now you have a metropolitan area network. So remember, you have a LAN, local area, you have another local area, you have another local area network here. They are all connected. You have a wide area network, a local area network. Again, the reason that we're going over networking, looking at all these networks, see how they're connected in local area or metropolitan or wide area. It's just to know that when you are in this type of environment and you are working in a SOC, you are responsible to protect all those networks. Your responsibility is to protect all those networks. Traffic flows from all this network globally. This network is global. Traffic flow from New York to Atlanta, Atlanta to China, China to UK. Traffic is flowing. And when traffic is flowing, there might be problems like hacking. The hackers, they'll be trying any way possible to attack any of your devices. And when they attack one device, if they attack this device, which is in New York, they can get into your network and they can harm all these devices. Their main goal is to just get into one. When they get into one computer, they're inside your network. So you have to be prepared and ready to protect that network. Because an attack can come from any part of your network. So that's why we are looking at a wide area network, we're looking at local area network, we're looking at personal area network, just to get an understanding that traffic flows from all these networks that are interconnected to each other. That business, communication, financial transactions going on within that network. And when those things are happening, that's what the hackers are praying for. They are looking for any means possible to get into any of your networks from any location. Because if they can get into your network, they can start causing damage and steal information from your network. So where the security comes to play is, how do you protect all these networks? You see the big picture now, you have networks spread all over, from locally to globally, wide area network, wide area, which is global. It's one company. They're all connected to each other. They are connected because they have to share information, the same company. How do you make that private? How do you make that kind of data secure? So when you come in as a security analyst, you are there to monitor this network. You sit at your desk, you are sitting right here. You might have this corporate network, global, but when you sit here at your desk, you can monitor things that are happening in this global network. And the way you will do that is the management tools that you have. The tools that we discussed the other day, the same tool that we have, the IDS, IPS tools, and all the other security tools that you have. That's what you will use to manage this global network. You are sitting at your desk. You have your SIM. Your SIM is collecting logs from all your all your global networks. Your SIM, you are sitting here, you are collecting logs. I don't want to make it feel like one SIM. You sit here and you have one SIM here, collect logs from all these global networks. So what will happen is, if you have one network here, China, one here, Europe, one here, Africa, they will have their own collectors. So the African network will collect logs from all the African computers. The Europe networks will collect logs from computers in Europe. And the China network collect logs from those computers in China, for example. When they collect those logs, they will go through the internet, through their networks. These are routers. These are routers on the network, routers. They will go through these routers and send that information to your management, to your collector that's sitting on your headquarters, for example. So all these logs will you'll see them on your headquarters. It has its own collector. So when they collect here, then you have that's where you have your SIM, your management console. Your management console of your SIM manages all these collectors. So when you collect this, when you sit on your SIM here, you can manage all these collectors. You can see traffic that's coming from all. So when you do a search from a user in China, from your office sitting here, you will see that information on your management console where you sit. So you don't have to communicate to somebody at a China location or Europe location to do a search for you, because all of them are interconnected. You just sit on your management console and do your analysis, investigation. You can investigate a user who is in China. All you have to do is type your username, because all these networks are connected to each other. Type your username, you see the user information the same as you will see in a user who is in the location that you are. So as an analyst, security analyst, you'll be protecting the entire global network if your company is global. If your company is just local, which have offices just say in Texas, you'll be protecting those companies, the Texas companies. Any questions so far on the global private network, personal network, local network, or global network? Okay, moving along. So in a network, you have devices that make networks to work together. We saw on our private personal home network that we have, personal network, we have a modem. Our modem is connected to an ISP. As you guys saw in my example, it was Comcast. And in my personal network, I have multiple computers connected to my modem. On the network, you have devices that make all those computers connect to each other. Before, on a laptop, the older laptops that we used to have and desktop, they used to have a network card. We used to call them network card, internet card, network card, internet card, the same thing. Internet card, not internet card. They used to have on the desktop, they still have the internet card. On the most desktops have the internet card, but most laptops now, they took out the internet card. The internet card, they don't have the port. You know, before you have an internet, you have you see this port here. Before we used to have them on our laptops. So that's an Ethernet port. That's a port where you put the cable. You put the RJ45. This cable is RJ45 cable. Before you connect to your network at the office, you have to, when you go to the office, you have to put your RJ45 to your laptop or your desktop. If your desktop was stationary at the office, you will always have this cable connected to your desktop at the office. If you have a laptop, you bring a laptop, you make sure your RJ45 is connected to your laptop for you to get network access. So the Ethernet card is on all desktop. If you have a desktop computer, there's an Ethernet card, and you have your network port where you put this cable. You put the RJ45 cable, you connect it to your network card. They have what we call switch. So you have your data center at your office. there's a data center where they have all the switches, the routers, all the servers, all your, the big computers. There's a room called a data center. You will have all these switches. This is a switch, example of a switch with all these ports. You see all these ports on the switch? Every port on this switch is connected to a computer at the office. So if you are sitting at your desk, this might be your connection on the switch. This might be a colleague, your next colleague sitting next to you. So every computer at the office is connected to the switch.
So at the office, how many computers are you allowed to monitor? Just one?
At the office? Oh man, when you start working as a security analyst, you go to some companies, they have 5,000 users. Some companies have 10,000 users. Some, like the global, we saw the global area, the global networks, the wide area network, which is global, may have 50,000, 100,000 users. For example, right?
Mm-hmm.
That's the amount of users that they have, right? So you will be protecting all those users.
Mm-hmm.
It doesn't mean that all those users will have issues at the same time, right?
Right.
And it doesn't mean that every time that an issue comes, it's just one person. For that kind of big company, right? For that kind of huge company, they will have at least more than 10 or 20 SOC people working in the SOC, right? If you're working in a small company, maybe with 1,000 users, 5,000, 1 to 5,000. You might have maybe three SOC analysts working in that, in that environment.
Mm-hmm.
So the connectivity we're seeing here, we're just seeing examples of a network, how a network is set up, just to have an idea. When you're a SOC analyst or security analyst, you don't go to the switches, you don't go to switch, you don't go and check what happened to us. There are switch people, there are network people. In your team, there's a SOC team, there's a network, there's a network team. So they handle the network. Anything that is related to the switch, to the routers, the network guys handle. But as a security team, you guys work together. Because if there's a problem with traffic, or there's a problem with a user, you might need some assistance to see if there's a problem with the network. Who do you communicate with? You communicate with the network team. The network team, they have access to the net. They know what's going on within the network, who is connected to what port, what switch on the switch. If it's how the wireless is. Now they have wireless network. How the wireless network is connected, and how users are connected to the wireless network. Who is the ISP? They know who is the ISP on that network. Where is the router? They have a wireless modem at the office. They have access to that modem. So as a SOC analyst, you don't really have to worry about what's going on. If there's no network traffic or if the network goes down, that's not That's not your duty. You don't even have to worry about that. The only things that you worry about is when the malicious activity occurs. That's when you get involved.
Hmm.
And the only reason I brought this networking slides up is just because, to just get an understanding, for people who haven't worked in a network environment, just to see how the network is set up. Because if you just have the idea how the network is set up, when we're doing the cyber security threats, how to do investigation of threat. When we say the router, you know what's the router. When we say the switch, the switch, we don't, the switch is not, the security analyst doesn't really care about the switch, right? But just to have an idea that the network is connected, how the network is connected from the switch to the computer, from the switch to the routers, how all these devices are in place. Because if you go to an office, they say, "Oh, the switch is down," or this, the router, something is wrong with the router. You understand, you know what's going on. That the router is what route traffics on the network. The route traffic from, if you are sitting at your desk, you communicate with a user from another location. The traffic is being routed by a router. So when they talk about router, the router is what is routing those traffic. The switch is just a switch. It's a switch. So it connects all computers that are in one office, one location. It connects them together. Network switch is used to connect multiple computers or communication devices. So your firewall is connected to that switch. Your SIEM device is connected to that switch. Your IDS device, your intrusion detection system device server is connected to that switch. Your email server, which is a device, email server might be a Windows machine, Windows server that has an email application installed on the server, is connected to that device. So all device that communicates on that network, they go through that switch. Any question about the switch thing? Like I said, this is just how network is set up. The devices that are set up on the network. Switch, your network card, wireless, Ethernet card, which is still a network card.
So, Prof, all the switches you're saying here, all of them are connected to different devices.
Right. So if you go, so in every company, right, they will have a data, like a data center, right? It's a room. A data center will be a room that is very secure, where they have all these devices in that room. When you open that room, you hear a lot of noise because all those devices are very
noisy.
Yeah, they take a lot of power, and they need fan. So you have to have a good temperature. air condition in that room to cool these devices down. Because these devices are your switches, your routers, your servers, or your mail server, your Windows servers, all your all those devices are in that data center. And how are those devices connected to each other? Through the switch. The switch is the switch is there. The switch is in that room too. But to connect all those devices together, that they can communicate with each other, will be through a switch to be on the same network. So this switch will connect all those devices together to be on the same network. That, in fact, so all these devices now, they'll have different IP addresses, right? The firewall, your computer, and every device that's connected to that switch have an IP address. For them to communicate, they have to be on this switch so they can talk to each other. So I can sit on, I can ping on from my desktop, from my laptop. I can ping a device that's sitting on this port on the switch. And that's what they are saying here. A network switch is used to connect multiple computers or communicating devices. Multiple computers or communicating devices. So all devices that you have, your security devices, your servers, your wireless, not wireless network, because wireless network will be part of the network, but it will sit on a different router, on a different wireless modem. But all the devices, before wireless came, everything was inside was inside the office, right? There was no wireless. You cannot just take a laptop and go to another location and start working, because before wireless, you will have to be connected from your switch. You have to be connected from your port. If this is your computer, there's a cable. This cable from the switch, it will go all the way. Even if it's 5th floor, if this data center is in first floor, and your office is in the fourth floor, for example, in the same building. The data center is on the 1st floor. Your office is in the 4th floor. This cable on the switch, they're going to route this cable. It's going to come all the way to the 4th floor to your computer. Did you get that? This cable from the switch, they will route this cable all the way to your computer. This is your computer. You're sitting on another floor, on the 5th floor. This is your computer. This is where the cable will come in. You see the same cable here? It's the same port, the same type of port. RJ45. RJ45, that's the cable. That's the port. So it will come here from your switch. They'll route this cable. It will go all the way to the 4th floor to your computer. That's how it was set up before. So if there's a route, if there's firewall computer here, it will come from a firewall to a port here. So the switch is just connecting multiple devices. Not just computer, but when we say computer, we're thinking it's just our laptop or our desktop. All the devices that is in your network. You remember those layers of defense that we saw on the slide yesterday that have eight layers of different security devices that are protecting your network, from firewall to IDS to all those devices. All those devices are on this switch. They are connected to this switch. From the device, they have their port. They have a port. They call these ports. So the switch is just connecting all those devices together. So we just finished a switch. Now we're going to router. A router. A router is like a modem that we just discussed when we started the private personal area network, our private network at home, which you have at home. Your private network at home has a modem. That modem is equivalent to a router. It's a router. It is a device at your home that is routing traffic from your home computer to the internet. It's routed from that router to the internet. In a corporate environment, there's a router. So on this slide that we saw switches, it will be on a rack. They'll have routers, they'll have switches on that same rack, they'll have servers on that rack. So if you walk in that room, they can have multiple racks with multiple, in a big company, when you walk in that room, you'll be like, wow, you see hundreds of routers of servers sitting on a rack. You see multiple switch. You see routers, different routers, because they're routing from different. So you see, when you walk in that room, you see that there are multiple devices that is attached to each other. The switch, the routers, the servers, everything is in that room. They're all connected to each other. Again, like we said, they are connected from the switch. The switch make that communication work. Is it? I mean, are you guys getting how everything is being connected to each other on the network and how traffic will flow? How we're going to start seeing how, when they are connected to each other, how traffic will flow from one device to another.
Yep. Track.
So from the switch these are all ports. These are empty ports. These ports are available. So if you buy a new server, you said, you know what, we need two Windows servers for some application. That will, So when you bring the servers, you put them on the rack. When you rack them up, you take one port, you take the wire, it goes to that new server. If you have multiple servers, you have 3 ports open. You have like, how many ports here? These ports are open. They are ready. So these ports are available for new connection. If you have new employees, so you can imagine how that data center room, how just the noise when you go in there, the noise with all those servers, all those switches, all those routers in that room. Router. So when you have all those devices connected to your switch, at that data center, and you have another office, maybe in another building, how do those two offices communicate with each other? How do those two offices, you have one office in one location and another office in another location. How do they have that data center? You have a data center, right? How does one office communicate with the other office? So the way traffic flow within one office to another is through a router. So the router will go from one port on the router, will go to your internet company that you're using. They'll have some kind of port. It goes to the internet company from that router. It goes through that company, goes to your other router, to the other company. So it routes that traffic. It will route traffic from one location to the other. That's what a router does. It routes the traffic. So the router takes traffic and transmit that traffic to another network. So you can have multiple networks that communicate with each other. The communication flows through the router. The router can be connected by cables, or they can go by wireless routers. And they go through, the wireless router go through your ISP. Every company has an internet service provider. Every company that have a network has an internet service provider. The internet service provider provides all the broadband lines, that allow that communication to happen from one location to another. For example, AT&T is your wireless provider, is your internet service provider. AT&T is a big company. They have wireless, they have communication, all over America, for example. So if you have one office in one location, AT&T is your internet service provider. If you tell AT&T you have another office in another location, they will provide you connectivity between that one location to another through the broadband. You can go through broadband, which is wires. You can go through wireless. So your company have acquired a smaller company. You're working for a big company and they bought a new company. The company is smaller, is in they say the company you acquired is in Dallas and you are in Houston. So now since you acquire this company, you have to integrate this new company to your network. So what do? You have to see what that company you acquired, what wireless network, what ISP they were using. Because you are using AT&T, they were using maybe Comcast. So those two companies, they can still communicate, they can become one. How do they become one? You can do a site-to-site VPN, virtual private network. That's something we're going to discuss in another session. A VPN. A VPN is just two routers. The router of your company and the router of the company that you just bought. Those two routers will connect to each other through virtual private network called VPN. When you set up the VPN between those two companies, the company you just bought, you set up that VPN connection, they call it site-to-site VPN. Those two companies will connect to each other. They'll have a connectivity. will become, now you can access the same application that the headquarters, the new company you bought, they can access all the applications that was in the headquarters, and the headquarters computers can communicate with the new company. So that's how those two companies will bind with each other through a VPN side-to-side connectivity. And the VPN happens on routers, one router to the other. VPN is a whole lesson, because it's very critical. But if you set up a VPN side to side and the connectivity works, there's nothing in between. You have the other company on a different location. You have your headquarters. The company you bought have a router, and your router in your company at your company. The two routers, they connect through side-to-side VPN. No, that's not part of the class, but it's just something to know how those two companies, that have offices in two different locations, how are they connected? It's through VPN, and VPN is configured between the two routers. That's a whole lesson by itself, how to make that connection.
Yeah, I mean, I try to, when I work from home, I use VPN too, so it allows you to work from.
Okay, you see, right, exactly. So the VPN that the VPN you use, right? It's a client VPN, right? So you have a client VPN installed to your computer. When you click on it, because you will log into your VPN.
Yeah.
Right. Okay. So there's client to site. There's a client to site VPN, and there's site to site. So yours is client to site.
Client to site, yeah.
Right.
Yeah, I think that's what it is.
Right. We talked about a gateway. A gateway. A gateway is where everything begins. You see, it's circled in red. A gateway, again, is your router you have at home. A gateway on a corporate network will be a firewall. Their firewall will be a gateway, because from the gateway you can connect to the internet. You can connect two different networks through your gateway. You see two different networks. You see servers. This is a server. This is a server. This is the gateway. They go through that gateway. All of them are communicating with each other. The gateway serves as an entry point and exit. Entry and exit point to any network. If you hear, they say, oh, the gateway, the traffic, it went through, is the gateway up, or, what's the gateway? You just know the gateway is either the firewall, it's the firewall. Because most firewalls are gateways. A firewall is a machine, but it's a gateway. It's configured, it's used to configure traffic that comes inside the network and traffic going outside the network. And the firewall is also a device that can protect the network. But it has the capabilities to act as a gateway. But it's a firewall. Firewall, when they say firewall, It's just a device that have firewall rules that give you access or deny access to application, to any object device that's in the network. You can block or allow traffic for you to access that device. You can be here. You want to access this server here. Guess what? You have to go through the firewall. The firewall can block you right here. That you coming from here, you cannot access this device over here. The firewall can block it. The firewall can say, I can allow all these users to access this device. The firewall can say, I can deny all these users from accessing this device. So the firewall has a big role to play. And it's a device that every company has a firewall. And the firewall is a gateway. Your switch, your modem at home is a firewall. It's a gateway, it's a firewall. If you log into that modem, you can block and allow traffic coming to your network. That's how the gateway is designed. It's a firewall. They call it firewall. It's a gateway. You can block, allow traffic. Every network has a gateway. You cannot build a network without the network starts from the gateway, because that's where traffic starts and traffic ends. Traffic comes in and traffic goes out. So every network has some type of gateway. So when you have office, they say, oh, the firewall, oh, maybe when you see traffic was blocked by the firewall, you know what that means. You know that the traffic came in, tried to come in, the firewall blocked the traffic. And when you do your investigation, you're investigating an IP that's external coming to your network. What do? When you do the search on your management console or your dashboard, your same tool, the management tool that you're using to monitor your network, when you do a search to see that IP, if the IP connected to any device on your network, when you do a search, the search will run and the results will show. It will tell you that the traffic came through an external IP, but the firewall blocked the traffic. And the firewall have a reason why it blocked the traffic, because the firewall have rules. Firewall have rules. Out of the box, when you buy a firewall, out of the box, it has rules. You can go there and modify the rules. You can go there and add more rules. You can go there and change the rules. But the firewall is a very, very important device in security. When they say firewall, it means that that's the gateway. That is where everything ends. But again, firewall is when we saw the defense yesterday, when we saw those multiple layers of defense, we saw that firewall was just one of the defense. You cannot just have a firewall and say, oh, I'm secure. Firewall can block traffic and allow traffic. Oh, I'm secure. I don't need no more security. I'm secure. No. Like we said yesterday, you need multiple layers. If you just have one layer, I bet you, I don't think you're secure. You need multiple layers of defense. And the layers start from the firewall to the IDS system, to the endpoint protection system, to the data leak prevention system, to the proxy, to the proxy servers. There are a lot of different security devices that you can add within your network. But the firewall is the gateway, is the number one, where you need to add multiple security devices. So when you're at the office and you are doing an investigation and you see that the firewall blocked the traffic, that is your resolution. If a user call that they receive some traffic from an external IP, or some external IP try to connect to their computer, you say, okay, let me check to see what happened. You say, what is your IP address? The user tell you, will give you the IP, or by the username, you can find the IP address on your network, on your security devices that you are using. You can find the user IP. If you get the username, you can find the IP address, their computer name, all that information. You can see that information on any devices that you are using for monitoring. So when you see that computer, that user's device, you can take that IP, you put it as the destination. The IP that is external, that the user said that it was trying to, attack or send some kind of malicious data. You take that external IP, you put as the source, because in this case, the external IP was trying to attack the internal IP. So now the internal IP is the destination, the external IP is the source. So you put the internal IP as the destination and the external IP as the source, and then you do a search. When the search runs on your SIM tool, it will come back and give you results. It will tell you when that external IP tried to communicate with this external IP. So this, for example, if this is the external and this is the internal. If you look here, internal have a different IP. External have a different IP. In my example, the external computer that is trying to attack is the source, because the source trying to attack it is the source. It's coming in, it's trying to attack. Who is it trying to attack? It's trying to attack the destination, my internal computer, which is the destination at this point. So if you take this IP, you put it as the destination, you take this IP, you put it as the source on your search, and then you put your search, you determine when did this occur, when did this happen. The user said it happened at 2 p.m. So you take those, you put your timestamp, you put 2 p.m. Or you put a timestamp from 1 p.m. to 2 p.m. and do a search. The results that you're going to see every communication that the external IP had with this internal IP during that time period. And if it's only one communication, you will just pick that particular communication and say, at this particular moment, this IP address was trying to, it will tell you what it was trying to do. If it was trying to do SSH communication, it will tell you the kind of communication that it was trying to, the kind of service that was using. SSH, if you try to FTP is a different communication you can use. Telnet is another communication that you can use. So it will tell you that the external IP was trying to telnet to your internal IP at this time. Your external IP was trying to FTP to your internal IP at this time. You will see it at the traffic or at that particular event. Your external IP was trying to SSH to your internal IP. So, is the external IP allowed to communicate to the internal IP with those services that I just mentioned, the SSH, FTP, Telnet? Yeah, we'll discuss those services on another lesson, another slide. Those services are ways that you can communicate from one computer to another, right? So the external IP might use SSH. SSH is a way to communicate with another computer to try to connect to the other computer. You can use SSH to connect to this computer. You can use FTP from one computer to another. You can use Telnet. Telnet are just communication ways you can use to communicate and connect to different computers. And hackers use all those techniques to connect. So when you do that search on your SIM, it will tell you that at this time, the external IP was trying to SSH to the internal IP. And the traffic was allowed. The traffic was allowed. When the traffic is allowed, it means that this firewall, your firewall here, allowed that traffic. So there's a rule on the firewall that says if anybody coming externally, going to anybody internally on your internal network, using SSH to connect to the internal network. SSH is a way you can communicate with another computer. You can use it to connect to another computer. SSH has a port number. Remember yesterday we said that every application that computer uses have a port number. When we say application, we mean web application, accounting application, database applications, all of them have port numbers. SSH, Telnet is a communication application to communicate and connect. It's an application. So this user, when he communicated to this other user here through SSH, he used port 22. Because SSH is port 22. That's the port number for SSH. FTP is another way you can connect to another computer, is port 21. So on your firewall here, you allow port 22. You allow, you did not deny. You did not say anybody trying to communicate to my internal network on port 22 should be blocked. You did not say that. You said if anybody coming externally to my internal network, going through port 22, firewall allow that traffic. But you can tell the firewall, if anybody coming from external IP, coming to your internal network, deny that traffic. You can allow or deny that traffic. So if it was denied, when you do your search on SIM, if it was denied, you'll see on your SIM search that the traffic was denied. So the user that called you to complain that there was an external IP that was trying to connect to their computer, based on your investigation, you tell the user, if the user open a ticket, user might open a ticket, you're working on this case through a ticket that was open. So when you are closing your ticket, you put there on the ticket that the traffic and external IP, you put the IP address, was trying to connect to an internal IP, you put the internal IP address. the firewall blocked the traffic. The firewall blocked the traffic. That's what you put on your ticket before you close. That's a resolution to close your ticket. So the user will be satisfied that the traffic was blocked. The traffic did not, there was an attempt, but the firewall blocked the traffic. That's how the firewall is very important. You know, you can allow and deny traffic. Another example, if this is your accounting department, and this is your database server, and this is your human resources department. You don't want your accounting department to communicate with the, no, you don't want the human resources department to have access to the accounting server. So all this is the same company, the same network. You have accounting, you have human resources, but you do not want human resources to see to get access to your accounting server. That's where the money is. You don't want anybody to go see the money. How much money is there? So what do? You come to your firewall. You say this accounting department, because now this is a group. On the firewall, on the network, this group have their own IP addresses in a subnet. They will have a subnet, or they'll have a VLAN. You know, I mean, that's a little bit going out of the topic, but they'll have their own IP address range. So you come to the firewall, or they'll have a group. You can put them on a group called accounting group. So you come to your firewall, you say, accounting group, when they try to access the accounting, human resources group, I'm sorry, try to access the accounting server. You tell the firewall, don't allow. So every time these users from the human resources group try to access anything in the accounting server, is blocked. The firewall block it. So the firewall can block internally. You can block traffic coming from external to internal, internal to external, internal to internal. You can tell firewall to do, it's capable of doing all those type of things. That's why the firewall is very important. And is the gateway, is the first entrance to your network and exit. The firewall is very important in security. You cannot work as a security analyst without understanding what part the firewall plays. What is the firewall? The firewall is the number one thing that you have to know when you get into cybersecurity, the firewall, because the firewall gives you access and deny access. And that's what security is. Security is, you don't want people that don't deserve access to have access. You want to give least privilege, the lowest privilege that you can give. If the accounting department, if the human resources department doesn't have no business to access the accounting server, give them least privilege, don't give them no privilege. If the accounting department, if the human resources department just need to access just a special section of the accounting server, you can give them just that privilege for that particular section. So in the accounting server, if you have where the money is, if you have where just the customers accounts are, you can give the human resources just access to look at the customers. And you can do all those type of things with a firewall. The firewall have the capability to break things like that. So that's how, again, that's how important your firewall will be on your network. Any questions on the firewall? It looks like everybody understands the firewall and what it does. Because we're going to have a quiz. We're going to ask what is the firewall and what does the firewall do and how, what part does the firewall play on the network? Any questions or no questions?
So the gateway is the firewall, right?
Yeah, the gateway, you can call the gateway the firewall, yes.
Okay.
Yeah. So your gateway, your modem at home, that's your firewall.
Okay.
Yeah, it's a gateway, it's a firewall.
Yeah, the route. So you can use a router as a firewall.
The firewall is not, well, you can use, the router has access control list, right? Access control list on the router. So you can also tell the router, okay, for example, okay, let's look at this diagram here. This is your firewall, right?
Right.
These are your routers.
Okay.
On these routers, they have their own access control list. So you can, on these routers, you can break them on groups. They call them VLAN, like different small groups of networks, of departments. So you can say accounting department, you put them on the VLAN, you put them on the different VLAN on your router. And you can tell your router, this department cannot communicate with this department, with the other department. So you can also do that because it has its own access control list. You can break different groups on the routers, and then give access or deny access from one group to another. And those little groups that you build on the router is called virtual, VLAN. VLANs, you can create VLAN and put different groups. So you can have, so if you have if this router have a network of 5,000 users connecting, going through this router here, you can break them down on different VLAN. This VLAN is accounting. This VLAN is this. This VLAN is human resources. This VLAN is warehouse. All of them still go through the router and go through the gateway and go to the internet. All of them have the same access, but you just break them. Just to make things easy for your network, you break things, put them in groups. So you have your network here, your internal network with routers. They communicate. The router communicates with your other servers. go through the gateway and the internet. When they put the red arrow, you can go to the internet. So routing is just understanding how you don't want to go to the environment where they say routers, you're like, oh, what's a router? Oh, there's a switch. You say, oh, what's a switch? Because any environment you go, the network is already set up. You just have to know how things are, when they say router, you at least you have an idea. When they say switch, you have an idea. The firewall, when they say firewall, you always hear about the firewall because the firewall is the one doing all the work, allowing traffic and denying traffic coming to your network. Let's take a 5-minute break and we'll come back and continue on networking. I have
8:30, 8:40.
I'm going to pause the record.